Welcome everyone to this special program where we bring to you the neuroscience of meditation. We also hope you take back with you some knowledge and resources that will help you advance your journey in meditation if you do choose to. Now, at the outset, it is fair to say that there is no scientific study more vital to man than the study of his own brain. And all human beings share basic anatomical circuits and synaptic interactions, but the precise pattern of connections and the interactions are highly variable from person to person. And therein, lies the source of the remarkable variation we see in human behaviors and capabilities, from, maybe the breathtaking dance of a ballerina to the elegant craftsmanship of a carpenter, to the shrewd judgment of a trader, to a criminal mindset. Everything is coded in the brain. And our brain makes us who we are, enabling us to perceive beauty, to react, to learn, and even ideation or imagination of a different future. And tremendous advances in neuroscience have occurred in the past 2 decades, with the 2010s being called the decade of the brain. And there has been a revolution in the field of neuroscience with the discovery that the brain is not completely hardwired and fixed, even in adulthood. It is constantly changing throughout a person's life and is remodeling its circuitry with each new experience. And everything that we do changes the brain in some way. When we practice a skill, the brain regions we use for that practice grow bigger. And when we do not use parts of our brain, those regions might shrink. And this is what scientists call neuroplasticity. Now, all this adds up to the tantalizing question for today. How does meditation change the brain? And for thousands of years, there was no way of testing scientifically whether meditation really worked. It was purely internal experience discovered and verified by each practitioner within their own mind and space. But fortunately, in the last few decades, new technologies have allowed us to objectively measure some of the effects of meditation, and the findings are fascinating. And in our program today, we intend to share with you such findings. Researchers led by Professor Sergio Elias Hernandez from the University of La Laguna in Spain, in collaboration with scientists from different universities, have been exploring for more than 10 years the benefits of the state of mental silence or meditation for a human brain. Professor Sergio, with his wealth of knowledge and experience that ranges from astrophysics to biomedical instrumentation through development of prototypes for medicine, to the neuroscientific study of meditation, is our esteemed guest today. He has 20 international scientific articles published, several R&D and innovation projects, and some patents to his credit. So let's go ahead and welcome him on the program. Welcome, Sergio.
So thank you very much for welcoming, for having me with you. It's for me a great pleasure. And also I want to congratulate you for your beautiful program. I have already seen some of your videos and they are really great. They are very interesting.
Well, thank you so much for that kind appreciation, Sergio. But we are very excited to talk to you and learn from you. And Sergio, it is said that the most complex system in the universe is a human brain, because it has about 100 billion neurons, which is, more than all the stars in the galaxy. And they're constantly communicating with each other. So studying human brain is imaginably very challenging. So tell us, first of all, about how all of this research got started.
So first, I should mention that I did start practicing meditation when I was a student in Madrid, at the Polytechnical University of Madrid, and I haven't always had this desire to know about myself, about the spirit, about this world, about the aim of our lives. So I've started in '87. I had the opportunity to have a very precious experience about meditation and mental silence that really allowed me to see a part of myself that was very important, to see my subtle body and my spiritual body. And since then I've been practicing meditation. And after I finished my PhD related between neuroscience and instrumentation, I really have this desire to do research about meditation and neuroscience. So at the very beginning, I had this desire, and I asked the people from my university, the tutor of my PhD, could do with start some research about neuroscience and meditation. And at the very beginning, they didn't were very much enthusiastic about the idea. But afterward, a few years later, in 2010, they came back to me and they say, I think we have all the possibilities now to start doing this research in meditation and neuroscience. So I was very happy. And since 2010, we have been doing our best to explore our brain in meditation, in mental silence from different angles or perspectives.
Wonderful. It's really amazing, how things have just turned a corner, and, there's so much interest, so much curiosity around these kind of studies now. Well, so Sergio, what I wanted to talk to you about first was that unlike, other animals, human beings spend a lot of time, thinking about what is not going on around them. We are contemplating events that might have happened in the past, might happen in the future, or perhaps may never happen at all. And indeed, stimulus independent thought or mind wandering appears to be the brain's default mode of operation. And although, this ability is a remarkable evolutionary achievement, cognitive achievement that allows us to, learn, reason, and plan, it may have an associated cost. And many philosophical and religious traditions teach us that happiness is to be found by living in the moment. And practitioners are trained to resist mind wandering and to be here now. Now, these traditions have all along suggested that a wandering mind is an unhappy mind. But the question is now, were they right all along? Because a 2010 scientific study by Harvard psychologists has gone ahead and said just that.
Well, what you say is very true. And this research that was published that you just mentioned in 2010 was very unique, and somehow it marked a very special event in neuroscience, because on this research was very simple and clever at the same time. They had around 5,000 volunteers from more than 83 different countries. And they were asking them, how do you feel? Where is your attention? What are you doing? Different questions. And what they saw was very clear. Those volunteers having their attention in the here and now were those who were happier. And those with their attention somewhere in the future, in the past, they were unhappier. So the conclusion was clear. So we have our mind that has this capacity about thinking, that allow us to go to imagine the future or to remember the past. That is very normal, but also if you go too much to the future or you go too much to the past, you are losing the present moment. And I always try to remember myself that the present is synonymous of a gift, something that is very precious. So today for neuroscience, not only this article, but many other different articles say that it's very clear that the best state for our mind, for our body, physical and mental health is to be here and now and to enjoy life. Because whenever we are in the past or whenever we are in the future, thinking about the past or thinking about the future, we are losing the present moment. And what is life? Life is in the present. Whatever was the past is gone, it's not there. And whatever is in the future, we don't know, but it's also not the reality. The reality is the here and now, and this is our capacity. So this is very clear today, but we have a tremendous tendency to be thinking and thinking and thinking. It's very difficult to reach this state of mental silence.
That is so true. That is so well said, Sergio. I think perhaps that's the hardest thing for us human beings to do, is to be in the present. And the only thing to lose is that, you just lose the present, and there is a cost to not being in the present. Definitely, like we said, it is a cognitive achievement, but it has a cost. And I think those scientists also said that whatever activity we are doing had only a modest impact on whether the mind wanders or not. And it almost has no impact on the pleasantness of the topic that the mind wanders to. And interestingly, they said, what people are thinking was a better indicator of their happiness than what they were doing. So that attention definitely, needs to be watched where it's going. Well, yeah, thank you so much for, elaborating that study and the findings. But Sergio, you yourself have done several studies over these past years, and let's talk about each of them. So let's start by talking about the study that you did in 2015, where you monitored the neural activity during the state of mental silence as achieved with the practice of Sahaja Yoga meditation. So tell us about what the control group was doing and what were the findings of this study.
Yes, this was our first research. We had one of the main advantages that we had is that we had access to a magnetoresonance scanner. As you already said at the beginning, a magnetoresonance scanner is a very complex instrument, very sophisticated. And with this instrument, we have the capacity to measure, to monitor the neuronal activity on our brain. So when we started, was our first project, is just to see what was the neuronal activity when the people reach this state of mental silence. I should say that because to reach this state of mental silence is quite difficult, there is the possibility, this specific meditation called Sahaja Yoga. One of the great benefits of this meditation is it simplifies a lot this possibility to reach mental silence. So for this study, we had 19 volunteers, and we asked them to meditate inside the magnetoresonance scanner. And they did 3 consecutive meditations. We asked them, just please try your best to reach this state of mental silence. And what we saw is that at the beginning, they were very short meditation, 2 minutes each. And at the beginning, there were neuronal activity on frontal lobes and temporal lobes. And this activity was interpreted by us like this effort to silence the mind, because our mind, if you do not put an effort, is wandering all the time. No, we have a wandering mind as by default. So on the first meditation, we saw this neural activity on the frontal lobe and temporal lobe, which associated with the effort to silence our mind. On the second meditation, this activity diminished a lot. And on the third meditation, there was a very specific area that is called the insula on the right hemisphere that was activated. And this is a very particular area. On this particular area, takes the function there is related with the interoception. Interoception is our capacity to monitor how we are inside. And this is very, very crucial for our harmony, because sometimes when we are here in the mind wandering, our mind is on one side and our body is on the other side, and somehow they are disconnected one from the other. And when you are monitoring yourself with this the activity on this insula, you can feel yourself and allow you to be in the here and now. And this insula has been also mentioned in other types of research related with meditation. And for us was a clear signal that those meditators, and even those meditators who say that they were more time in mental silence, have even a greater activity on this area. So there was a close relation between this state and here and now, mental silence, and activity on this area, the insula. This is what the main result that was published on, as you already said, on this 2015 article.
All right. So your control, what were they doing?
No, on this research, we only had meditators. Okay. We have 18 meditators, and they have as a control, they have at the very beginning, they have it was to monitor different states. And we compare the state of mental silence with the state of having their attention on breathing without meditation. But on this very first study, we didn't have a control group as such.
Got it. Okay, got it. Yeah. Okay. But in the abstract, I think it was mentioned that the state of mental silence as experienced in Sahaja Yoga meditation, so far as your study was done, was only investigated through the use of EEG, and your study was able to do it with a better resolved technique of functional, MRI to more thoroughly investigate the precise neurofunctional correlates of this state. So did you want to elaborate anything to that intent?
Well, those previous studies with electroencephalography or EEG were very important also. They also mentioned how the activity, somehow there are different types of technologies, and they complement each other. Through EEG, you have the possibility or the capacity to measure with precision in time, around milliseconds, but you don't have the precision in space. Because on EEG you just put electrodes on the surface on your scalp, but it's inaccurate to say where is the activity, is here or there. It's mainly when the activity is on an area like the insula that is a few centimeters inside our brain. So with the magnetoresonance scanner, neuronal activity or fMRI, we don't have this resolution in time, we have a resolution of seconds, but we can have a precision in a space around millimeters. So we have in EEG a precision in time, but with fMRI we have the precision in space that allow us to see which part of the brain is related with this state of mental silence.
Awesome, awesome. That's really very helpful to know. Thanks for sharing that with us. So, Sergio, there is growing awareness that distribution of gray matter volume in our brain has an important role on our mental health, our behavior, our cognitive functions. And in your next study that you did in 2016, you were able to conclude how the anatomy of the brain is positively altered with long-term Sahaja Yoga meditation. But before you share your findings on that one, tell us a little bit more about gray matter as it relates to us human beings practically, and also tell us about voxel-based morphometry, which according to your abstract is a new approach of looking at structural brain changes.
Well, yes, answering your first question, we should know that our brain has three different types of matter. The gray matter, that is mainly the nucleus of the neurons and the connections or synapses between neurons. The gray matter, then we have the white matter that have the long connections or axons, and we have also the cerebrospinal fluid that is a liquid that is in the holes of the brain. The gray matter is quite important because when you were talking at the beginning about neuroplasticity is the best way to measure it because we are doing new connections every moment. Our brain today is different, a little bit different from our brain tomorrow, because there are a new connection, that new experiences, new things that we have learned. And depending on the areas that you use more, those areas get larger gray matter because it creates new connections between the neurons. The gray matter is quite important because it somehow allow you to function as a human being and to develop your different capacities. Also, it's important to know that when we get older, we are losing gray matter. When we are around 20 years of age, half of our brain, 50%, is gray matter. But when we are around 60 to 70 years of age, our gray matter diminishes to 40%. This is normal with aging, but as we get older, our capacities to learn new things, to open to new experiences is a little bit less than when we are much younger. Also important is to say that there are important diseases like schizophrenia or depression or anxiety or even stress that are correlated with a loss of gray matter. So to keep your gray matter intact is very important for your mental health.
Mm-hmm. Okay.
And the second topic, the voxel morphometry, voxel-based morphometry is a type of research in which you can, when you acquire the images of the brain with a magnetoresonance scanner, you have the capacity to somehow locate, first of all, you have to differentiate what is gray matter, what is white matter, and what is cerebrospinal fluid. Mm-hmm. There is some programs with mathematical analysis. So it's a semi-automatic methodology that allow you to measure the gray matter and to compare gray matter from two different groups, like we did. We compared the gray matter of volunteers practicing Sahaja Yoga meditation for more than 5 years and another group, both group with 23 volunteers, similar age, similar education, exactly the same number of men and women. and everything was similar, with the exception that in one group they were meditating daily for more than 5 years, and in the other group they didn't have experience on meditation. And with this voxel-based morphometry is the most used technology to measure differences in gray matter volume.
All right. And I think you observed overall with meditators, there was an increase in the gray matter overall, right, for this study?
Yes. We saw that there were, this type of study has been done with many different populations, from the taxi drivers, from people learning to juggle to keep the balls in the air, with musicians. And what we have seen, we have learned a lot about our brain, and we have seen what we already said, that those parts of the brain that we use more get larger gray matter volume. And also in meditation, we saw in the other types of meditation, they published that those parts related with the attention and the control of emotion got larger gray matter. But in all these studies, the gray matter difference was located in a very precise area, very small, like a few millimeters of cubic of volume. But what we saw that the difference was in the whole brain. And this is the only study, as far as I have seen, is the only study that I have published a difference in gray matter volume in the whole brain. And this 7% that we saw, the difference between meditators and non-meditators, is the largest ever published difference in gray matter volume. It's something unique. For this, some people say, no, 7% looks not so big. You have to keep in mind that such a severe sickness like schizophrenia is correlated with a difference of gray matter around 2 or 3%. Another many important mental diseases are correlated with a 1, 2, or 3% when you compare a healthy group and a group with these severe diseases. So we compare two groups of all volunteers were healthy. They have to pass a kind of a filter or examination, and both of them were healthy. And this is the biggest difference in gray matter volume. So we are very, very enthusiastic about the research. And this research has some implications in the sense that it was one of the most read articles. And a few, just last month, at the end of July, the journal, the one which was published, PLOS ONE, said to us that it was one of the most cited scientific articles that year. So we were very happy.
I was so glad when you shared that email with me, and it was so wonderful to see that, this is the most downloaded article or study so far. And also, very encouraging is the fact that the percentage increase in the gray matter volume that you've reported with Sahaja Yoga meditators is the largest ever that has been reported in the scientific journal. So this is really great information over there. But I think another point in this study that I wanted to discuss with you was the tendency line graph that you did. And you concluded with the use of that graph that the gray matter volume diminished very slowly in Sahaja Yoga meditators than the non-meditators. So is that correct?
Yeah, that is correct.
Right.
So we saw that the meditator not only have a larger gray matter volume, but when you see the tendency in a figure where you depict the gray matter volume percentage with age, you see that, as I already said, around 20, you have 20 years of age, you have half of the brain, around 50% if gray matter. In both groups were the same. But when we are in the 60 or 65 years of age, the tendency line for non-meditator was around, as I already said, around 40% of gray matter at 65 years of age. But meditator, instead of 40, they have around 44%. And this is quite a big difference. And this is an indicator that also what we have seen, that the meditator has this benefit on the gray matter, and the brain is younger and healthier and more capable for doing and learning new things.
Right. Isn't that awesome? Not only does the gray matter increase to a very significant degree, it also diminishes very slowly. That's a really interesting and very valuable study, I must say, Sergio. And I do want to congratulate you on that. But from what I understand further, that in the study that you did in 2020 was an extension of your earlier study, this one where you just concluded that, 7% increase in gray matter. But in 2020, you analyzed in more detail how the gray matter differences are distributed across whole brain. So tell us your observations and conclusions of this research, and how does it translate for us in our everyday lives?
Well, when we published our first study in 2016, we used the standard statistic. On this standard statistic is just to compare the whole brain. And it's like compared to mountains and the peaks of two mountains, and somehow it's the assumption there that the whole volume of gray matter is similar, because in our case it was not the case. There was a difference of around 7% of gray matter volume. We had to somehow to introduce a new methodology for the statistic. So we asked one of our professor in my university, who is an expert on statistics, to help us to compare area by areas, how was in which area this difference was more pronounced or larger. And we saw that in all areas, almost we did two divisions of the brain. One in large areas, like we call it the lobes, that frontal, temporal, occipital. And also we did a comparison with small areas to divide the brain in 116 areas. We saw that in all areas, meditators had larger gray matter, but in very important areas, this larger gray matter was statistically significant. When I say statistically significant, means that it was not by chance. It was very clear that there was something different in one group respect to the other. And what we published in 2020 was that both frontal lobes on the right and left hemisphere and the right temporal lobe and other areas, but these were the main areas. In those areas, meditators have larger gray matter volume, statistically significant. And these areas, like both frontal and the right temporal lobe, are very important because somehow they define our personality, they define our capacities to react, they define our capacity to take our decisions. And so they shape in a way our personality. And you have a larger gray matter there is very important. Also, you have to think that when you are, the frontal lobe is the part of the brain that takes large, for example, in adolescence, they are growing the gray matter there. So when you reach adulthood, your frontal lobes are really in the normal shape. And for example, for an adolescent, it's very complex sometimes to control their emotions, to control their feelings, because those parts of the brain are not fully developed. But if you have larger gray matter volume there, it means that your capacities to control your emotions and to control your attention is larger, or is much better than a non-meditator. So this is what the main results that we publish on that article.
And I think that being said, it then makes all the more sense for adolescents to start practicing meditation, at that age. Like you mentioned, it's harder for them to, get through their emotions. So yeah, I wish, more of us could utilize that knowledge. But then, Sergio, there were two more studies that you did, one in 2018 and another just last year, which essentially observed the strengthening of attention and weakening of mind wandering. But tell us more about those two studies.
This was the other type of, let's say, of methodology or technology related with the images from the magnetoresonance scanner. There is a technology that is called functional connectivity. Today, we know that different parts of the brain, although they could be apart from each other, they could be cooperating in order to enhance complex functions. What we study on that research was the functional connectivity on this state of mental silence and also on the state of resting, on resting state. On resting state, normally you have your mind is wandering. For example, if you are waiting just for the doctor, or you are waiting in a queue or whatever, normally your mind is wandering. Tomorrow I will do this, or yesterday this happened, or that. So what we saw is in resting state, meditators were not with their mind wandering. They were more in the here and now, which is much better for our mental and physical health. And in mental silence, we saw that there was a very particular specific area that is called anterior cingulate, just a few centimeters behind the central of our forehead. And on that area, those meditators having a better meditation inside the magnetic resonance scanner, and also having frequently reaching this state of mental silence on their daily meditation, they have larger gray matter volume there, and they also have the group of meditators have larger gray matter there than the non-meditators. And that area, the anterior cingulate, was cooperating with the insula on both hemispheres and the putamen. And the insula, as I already said, is related with interoception, and the putamen is related with the state of joy, of somehow happiness. But the happiness that is not, is just very peaceful. And this somehow gives us a definition of this state of mental silence. Mental silence, you are here and now, you stop your mind wandering, but you are with your full capacities, and you're also in a state of peace and joy. You just enjoy living. And this was very, we were very happy that we could see this on our research on this functional connectivity that we published in, as you already say, in 2018 and this year, 2021. Mm-hmm.
Awesome. That's really some great studies over there. So Sergio, I know you have also spoken about the linkage of music and the brain in another interview of yours, but would you share with our listeners here any information around that?
Well, music, we should know that our brain has two different hemispheres, and these two hemispheres are connected with a kind of highway of white matter. This is a corpus callosum. And these two brains, in a way, they have two different behaviors. No? The left brain is more for the rationality, even for science, to focus to plans. And this is the left brain. And the right hemisphere, or the right brain, is more related with art, with emotions, and also with music. And also there is another part, a very important part of the brain that is a little bit more inside, that is the limbic area, that is more related with this state of mental silence. It is said that it's the last center of energy, or that is called chakra. And this right hemisphere has more connections with this limbic area. Through music, you can reach, somehow it facilitates your capacity to reach this state of mental silence, to reach the joy. And also music is very much related with emotions. And in yoga and in Indian classical music, you have a very specific type of music that is, probably you know better than me, that are the ragas. And with the ragas, you can somehow touch every aspect of this subtle spiritual body, and to enhance all these wonderful qualities that we as human beings have, that we can reach also through meditation.
This is such valuable information, and I really want to thank you, Sergio, for all of this dedication that you've had for conducting these studies for the last 10 years. And I would say this is a very, very valuable contribution that you've made to the societies. Do want to thank the founder of this meditation. This is an invaluable gift to the humanity, honestly. But I do want to thank you for taking the time today and coming to us and speaking to us about all your findings in such detail and giving us your time. Thank you so much, Sergio.
So thank you very much. I also would like to, if you allow me, just want to say that I was not alone in this research. I had the possibility to collaborate, as you already said at the beginning, but I want to say that we are doing research on a group. And for me, it's a great, let's say, a great pleasure and a great honor to be cooperating with researchers from different universities around the globe. And they really help me a lot. And so it's not only my doing, we are around 6, it depends on the article, but normally we are 5, 6 or 7 researchers doing this research or these studies, and they do as much as I do. So it's not only me.
Yeah, that's true. And nothing can be achieved alone. So do understand there's a whole team of you working towards that. And do want to extend my thanks to all of them as well who've contributed to this research. But once again, thank you, Sergio. It was really wonderful talking to you today. Thank you.
Thank you. It was wonderful for me to be with you today.
Thank you.